Hi everyone. In today's session we are going to see about computer organization and architecture. Today we are going to see about multiplication problems and unit 2. Basically the multiplication is performed on numbers. The numbers are of two categories. Either it is of positive. We are going to see about multiplication of positive numbers. In this, the multiplication can be performed by humans in manual, and in the system the multiplication will be performed in an sequential way. Today we are going to take a problem which is of both positive numbers, and we are going to solve it using manual and sequentially. In this, the multiplicand value is 13 and the multiplier value is 11. The first step is we have to convert both the numbers into binary equivalent, right? 13 divided by 2, it is of 6 and balance 1. Then it is of 3 and balance 0. Divided by 2, again it is of 1 and balance 1. We have to write in this order. So it is written as 1 1 0 1. Okay, 13. Then again for 11, by dividing 2, it is of 5 and balance 1. Then again divided by 2, it is of 2 and balance 1. Then again divided by 2, it is of 1 and balance 0. Again we have to write in this order, right? So 1 0 1 1, it is for 11. We have converted both the numbers into binary equivalent, and in this we are going to start solving the problem. In this, in matrix multiplication, let's take it here 1 1 0 1 and 1 0 1 1. In this, first we have to start from the last bit, right? The last bit is 1. We have to multiply it with the multiplicand. 1 into 1 is 1, 1 into 0 is 0, 1 into 1 is 1, 1 into 1 is 1. Then we will take second number 1 into 1, but the thing is that we will be placing by lifting the last position. So we have to leave it here and we have to start writing from here. 1 into 1 is 1, 1 into 0 is 0, 1 into 1 is 1, 1 into 1 is 1. Then with 0. For this we have to leave another one position. Finally we will start from here. 0 into anything is 0, so it is of 4 zeros. And finally again last 1 1 0 1 1. We have to perform the addition. This is a blank, so 1 and 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is again 1, then 1 plus 1 is 10, and 10 plus 0 is 10, 10 plus 1 is 11. So we are placing it here. This is an carry. 1 plus 1 is 10, so we are placing 0 and 1 is here. Then 1 plus 0 is 1 and 1 plus 1 is 10, so we are putting the carry here. Then in this is also a carry bit. 1 plus 1 is 10. So this is our final multiplication answer for performing and a matrix multiplication. We are going to see the same problem and a sequential. Let's see how the system solves this problem, because the processor will solve what are the problems we are giving to the system, will solve it in a sequential manner only. Let's see how it does. This is nothing but an multiplication, matrix multiplication representation. We will be placing each bit in a by placing, leaving out the one position, right? So that is how represented here. This is the multiplicand and multiplier representation, and these are the product terms which we arrive. Finally we will add all this and we will be getting the final product. Okay, and this is nothing but the array implementation bit cell which is functioning inside the system. It will be consist of an full adder, because full adder is capable of adding 3 numbers, and it gives the output of sum and carry, which was seen in the previous sessions, and it has an AND gate to perform the operation. Let's move to the next, and this is nothing but the representation flowchart for the multiplication under sequential method. Okay, first let's see how to perform the operation and solve the problem under sequential method, and let's see about this diagram. Okay, in this is the sequential representation. Starting, as said, we are considering the two numbers 13 into 11. Okay, this 13 is the multiplicand and 11 is the multiplier. In this, multiplicand is represented as M and multiplier is represented as Q. First, we will set the multiplicand. Multiplicand 1 0 0 1 is written at the top. Okay, and then in this, the Q value, second 1 0 1 1, which is for equivalent 11, is written here. In this, whatever we are performing in a sequential manner, right? So the multiplication will be performed step by step. We need an temporary register to store the output values. That temporary register is the accumulator we are taking here. Okay, A stands for accumulator. The accumulator size must be equivalent to the multiplicand M. Since the multiplicand bit is of 4, we are considering the accumulator size as 4. And we will be having the carry, right? So we are setting an carry C bit also. This is the initial step for performing multiplication under sequential manner. And in this, the total number of steps will be calculated based upon the size of Q. If the Q is of 4 bit, we have to perform addition and shift for 4 cycles. Okay, our number is 11. It is of 4 bit 1 0 1 1. So we are performing the operation for 4 cycles. It is of only 2 steps: add or no add and shift process. Okay, first we have to take the last bit. Okay, last bit is 1. If it is 1, we have to perform add and shift. If it is 0, we have to shift along, no add will be done. Okay, that is the algorithm. Since it is 1, we will be adding the value of M to the accumulator. M plus A will be performed. This is the addition operation. Our accumulator is of 0, so we are adding M value with this. So in the add step, it is getting updated as 1 0 1 1, and we have no carry, so the carry is 0. And the first step is over. Second step is shift process. In this, we have to perform right shift. Okay, in this, the bit this one is shifted here, and this 0 is shifted here, and this one is shifted here. Finally, this one is shifted here, and this 0 is shifted to this position. One is shifted to this position, and another one is shifted to this position. This carry is shifted here, and again the carry will be 0. Combinedly, this addition and shift is of first cycle. We have completed for 1, and then we have to perform the second cycle. During the second cycle, we will be taking this number only, since we are considering the last bit. Our last bit is 1, so we have to perform addition. We have to add M plus A. Okay, our accumulator value is this 0 1 1 0 1 0 1 1 0, and our M value is 1 1 0 1. We will perform the addition. It is of 1 1 10, then 10. This 1 goes for carry. Okay, we are writing the answer here. The Q will be directly written the same value, and we are updating the value for accumulator alone. So we are writing this 0011 to the accumulator and this 1 for carry. This is for addition, and next we are performing the shift operation. This is right shift, so we are performing shifting all data one bit right. That's it. And finally second cycle got over. In third cycle we again will be checking the last bit. Since the last bit is of 0, we will be performing no add operation, so the same value will be written down. Okay, since it is of no addition, the q will be same and the accumulator value has not changed. We are performing shift for second step. In shift, it is right position, it is carried for 1 bit, so we are performing all shift, and then we are going for finally fourth cycle. In fourth cycle we will be checking the last bit. Since the last bit is of 1, we are performing addition. If it is 1, we have to add m plus a. M value is 1101. A value, currently what is the a value? 0100. If we perform add 10, 10, again 1 is for carry. We will be writing this answer in the accumulator space. Okay, 0001 and 1 for carry. We have completed the add and we have to perform the shift operation. It is of right shift, so shift everything for 1 bit position. Okay, that's it. This is our final product. After completing the fourth cycle, whatever the answer we are receiving will be the output of the multiplication product. For this, we can check the concurrency between the manual and sequential operation. In manual, what is the result we have got? Manually we got 1 0 0 0 1 1 1 1. In sequential we have got 1 0 0 0 1 1 1 1. And finally our sequential multiplication got completed. And this is the diagrammatic representation for performing the operation. This is nothing but, as said earlier, we will be having m and q. It is written here, this multiplicand, and q value is multiplier, and based on the size of m we will be setting the accumulator, and for carry we are having all addition operation will be performed in the n bit adder, and all the control signals will be given using control sequencer. This is nothing but the add or no adder control operation. This is the flow of sequential binary multiplication. That's it for today's session. Let's see about signed binary multiplication in next session. Thank you.